Every Codex task begins with an important decision. Is the request actually ready to execute? A prompt can sound clear while still missing context, scope, or a way to prove success. Once the agent starts working, those omissions become expensive. We built before the agent to solve that problem. It is a local preflight for Codex, powered by a fine-tuned 26 million parameter needle model. Needle runs on the CPU through Cactus CQ4. It suggests how the task should begin. Deterministic code checks that suggestion, preserves the user's exact words, and keeps execution under human control. We call this meta prompting. The public site explains our research. This local app is the working product, running the package model without an API call. Let's start with make the API fast enough. In about 4/10 of a second, Needle recognizes that this request is not ready. It recommends asking a question. Trusted code turns that into something concrete. What performance target and representative workload should define success? Because the request is still ambiguous, no Codex launch plan is created. Now imagine a platform team needs to audit tenant authorization and add attack focused tests. Needle recommends a security review and repository inspection, but it misses something important, the verification. This is where the architecture matters. Deterministic policy adds the missing verification gate. The compiler expands the approved actions into reviewed security instructions while preserving the original request word for word. A real codex command is prepared, but this page cannot launch it. The user still has control. For a precise one-line change, the system behaves differently. Needle selects a quick patch and gets out of the way. The handoff stays focused and does not invent extra requirements. The model is useful, but we measured its limits honestly. On 96 product prompts written outside the training generator, tool name F1 was 56.5%. Exact action sets were correct 37.5% of the time. It caught 14 of the 18 clarification cases, but incorrectly acted on 4. That 22.2% unsafe rate is exactly why Needle recommends, while deterministic policy decides. Even so, the local runtime is fast. It averaged about 350 milliseconds and 97 megabytes of engine memory on an M4. One of our most important findings came from failure. Cactus constrained tool names and argument keys, but not enum values. We redesigned the contract as 14 parameterless tools and restored 100% allow list validity. That changed our idea of meta prompting. It should behave like a compiler, not a prompt ghostwriter. Codex with GPT 5.6 powered the entire engineering process. We used it for primary source research, data generation, CPU fine tuning, ablations, runtime debugging, testing, product development, as well as the public site. The repository contains 21,592 auditable rows across the main experiments. That finished router makes no OpenAI model call. Codex remains the downstream coding agent. A tiny local model makes the suggestion, deterministic code, and the user keep authority. So that is before the agent. Thank you.